Yeah, physics time. The objective, we're having a discussion. Let's make up an objective. The point of my saying it's a discussion is that I want you to have your stuff. That's part of why you already know some stuff, right? You've already learned some stuff. So now we're going to discuss what all we've learned. I hope you've learned some stuff because you read this. What I'm going to be supplying you with my ideas about came from the same place you got your ideas. So let's talk about it together. Another thing I want to say is that for the same reason, this is not a lecture. I'm not just going to tell you what's in the book because you've already read the book, thing the first. And second, there wouldn't be any time for me to say what I want to say, which is all about the things I think about this and ways that I can help you do a good job remembering and applying it. And I want to hear your ways that you are thinking about it. Let's address this, or let's title this, Science. Based on what you've read, what would be a good objective based on this? I'm going to try to think of one too because I actually truly have not thought of one yet. So the objective, students will be able to, students will be able to differentiate the realms of, slam the door, differentiate, what's that verb mean?
You're going to look it up?
Yeah, look it up.
Yeah, look it up in Alexa now.
I'm going to say, hey, here's an ELA question that you should know.
Okay.
When do we use between and when do we use among? These are the same kind of word.
Between is like probably 2,
Yep.
and among is like a
Yeah, more than 2. Yeah, you're exactly right. Between is for, so like between Lily and Alexa, I like Lily's shoes better. I can't actually see your shoes, Alexa, it's just an example.
Yeah.
Please don't be offended.
My shoes are
Between Alexa and Lily, that's because of you two. And then among the 3 people in this room, I like the T the most. Once again, that may or may not be true. But I'm going to put here, differentiate among, what's that tell you?
There's more than one.
Yeah, differentiate among science, technology, art, and religion. Uh-oh, he said the bad word that we aren't allowed to say.
Yeah.
No.
Yes.
No, we are going to say it, and we are going to talk about it because it's important that you understand this. So we're talking about science. What makes something science? In fact, I actually just filled out a forum post for my class that I'm taking about what is science. What makes it science? What are some things about science that make it useful? I want to hear your ideas. No, you don't have to look it up. Just tell me. What makes it science?
What makes it science?
like experiments,
Okay, so there might be experiments.
force.
Force?
Well, is it
Yes.
force and
Energy.
energy? And
So let's say this. So there's force, energy, matter, chemistry, all that stuff kind of goes into the content of science. So to some extent, the content determines. Like, for instance, what I mean is that there is a science of dog food. I'm sure there is. There's a way that people think about and look at and develop types of dog food and ways to administer dog food and all the different things about dog food. But that doesn't mean that going into the grocery store and buying dog food is science. You know what I mean? Like anything can be within the content, but not every content applies to science. I picked dog food because it's innocuous, but what I specifically am getting at is that there are some things that science doesn't even deal with. And it's not a shortcoming of those things, and it's not a shortcoming of science. I'm being a little bit still more veiled, but what I mean is religion. Just because religion exists doesn't mean, it's not a shortfall of religion that science can't be applied to it. It's not a shortfall of science that it doesn't apply to religion. They're just completely different things. We'll talk about that a little bit more later. But there are certain contents that we talk about in science. It's very broad. Everything in the physical world is science. But ghosts, that's not science. It can't be science. God, that can't be science. It cannot be within science because it cannot be shown to be false. So, what else is about science? We'll get to both of those later. So we have experimentation. We have some kinds of content are within the realm of science. What else makes it science? Well, let's... I don't know if you remember this, but when you were in physical science, I was trying to tell you guys about my idea of the scientific method. I think that might have been the year where I kind of came up with this solidified idea of the scientific method. Do we always have to have experimentation when we're doing the science? No. My example was, I told this to the 8th graders and the 9th graders this morning, An example would be like if you two, you guys hang out, if you two are walking out of school, and Lily says, "Oh, what kind of tree is that?" I don't know why you'd be interested. I'm sometimes interested in trees, but she says, "What kind of tree is that?" How would you find out?
Look at the tree and look it up.
You would probably do it. But that is science. My point is that is a kind of science. So there's a certain methodology, and that word means a way of doing things. There's a certain way of doing things that is science, and that's what I want to focus on. So there certainly is a kind of content that we talk about, like this is stuff like the vocab that we have to know to get by, and don't make any mistakes, a large part of the class will be this content. It's also the math, although the math kind of is a type of methodology too. But a large part of that we have to know in order to be good scientists, but we're doing science even if we're not good scientists. When you say, I wonder what's in this almond milk, you look at the back of the crate of almond milk to see what's in it. That's science. You're making an observation, or you're asking a question. I wonder what's in this almond milk. You are doing some research. In that case, just looking at the ingredients list is research. And then you might say, "Oh, Dad, there's almonds in here." And that's communication. And that's another thing about science is that there's communication. There's communication. Is every kind of communication science? No, but I would say pretty much every kind of science relies on communication. It's useless if you don't communicate it. Let's talk a little bit more about math real quick here. Why is there math in science? This is much to the chagrin of some of these cowboys. Why is there math in science? What did your book say? And I like the way your book says it, which is why I ask.
It says the math is the language of science.
Yeah, and I like that. Math is the language of science. Why? Why?
They're unambiguous when explained mathematics.
Unambiguous. That means if someone is doing good math, the results, if they are shown to be mathematically true, if the evidence suggests these things mathematically and they have this mathematical relationship, that is unambiguous. That doesn't mean it's always right, and it doesn't mean that it's always accurate, or it doesn't mean it always is precise, but it does mean it's unambiguous. Whether the math is right or not, or applies or not, doesn't really matter, but it is unambiguous. It means the same thing to you as it does to me. Whereas if I say dog food, that means a different thing to you as it does to me, even if it's just a small difference. You know, like if we're talking to someone's great aunt about dog food, she might be picturing canned dog food for her little miniature schnauzer that has 100 medical problems. If we're talking to some rancher, the dog food might mean whatever the leftovers were last night. Like there's differences in dog food. But if I say x plus 3 equals 5, it is unambiguous. X can only mean one thing, as long as you have the right framework to build this math. Like if you know math, X can only be one thing here. So that's what we mean by math is unambiguous. So as much as we can, we try to get things in math. Mr. Shilley and I talk about this a lot, that in the realm of education and psychology and kind of these looser disciplines, it's really easy to weasel your way out of things. Like you can use a lot of words that don't mean a whole lot to explain something that you believe, even if it's not truly what you believe, or even the truth. You know, like if it isn't the truth, you can say, I think we should do this because blah blah blah. You can talk for a long time, but there's no weaseling your way out of x plus 3 equals 5. It just has to be 2. And the further something gets from math, the less mathematical it is, the more ambiguous it is, and the harder it is to say we can show this to be true. In math, we show things to be true all the time. We can't even, in science, we can't even really say, we never prove, this is something I really want to talk about, we never prove anything in science. I don't want you to use that word. I don't like having words that I say, oh, you can't say that. Like when I worked at Fort Robinson, I worked in the information booth, I was told, you cannot tell people I don't know. I disagree with that, because sometimes I don't know. And I think it's like I tell you guys I don't know things all the time. I think it's a valuable way for you to see that I'm not perfect. I don't have all the answers, but I will help you find out. But I do want you to stay away from this in science, because mostly because people have a misconception about what this means. When we say that something is proven, we mean we have shown that it is always true, it has always been true, and that it will always be true in every single situation where that thing could occur. So if I say, I have proven that cats land on their feet when they fall. Have I done that for every single time? Every single time? No. Like maybe usually a cat, when I throw it off a roof, falls. But what if I have a cat cannon and I launch it at 700 miles an hour into the ground? Is it going to land on its feet? Maybe not. Right? So we can't say prove, but you can see how that could be a problem, right? Because prove specifically means it will always be true. We can't ever prove anything because we don't have full knowledge of all the different circumstances under which this can occur. So we don't say this, but we could say the evidence suggests that cats fall or land on their feet when they fall. That would be a valid thing to say. So I want you to do instead, evidence suggests. And I like this phrase, evidence suggests, because it also leads us into the next thing, that it helps us stay away from things that are outside of the realm of science. Keeps us within the realm of actual science. Scientific things must be able to be disproven. That's the criteria. Must be able to be disproven. Everything else that we need to know, I think you have in your book. This is the main stuff I want to get. I do usually like to talk about the difference between laws and theories, but we obviously ran out of time, so make sure you study up on that. You might even consider watching my video from last year to know what I think about the difference between laws and theories. But this is the main thing I wanted to get at, is that in order for something to be considered within the realm of science, it must be able to be disproven. We must have a conceivable way that we can say, oh, I can think of a way to disprove this, like my cat example. If I say cats always land on their feet, can you think of a way to disprove that? Yeah, pretty quickly. And that means that is a scientific question. If you can think of a way to disprove it, it's science.